So, hello everyone. In the previous chemistry lecture, we discussed the first 20 problems of IBHL 2020 Chemistry Paper 1. And in this video, we would be discussing the problems from question 21 to question 40. So, let's start with the paper. The first question asks us that which graph represents the relationship between rate constant K and temperature T in Kelvin. Okay, so in order to solve this question, we need to know the relationship between rate constant and temperature. Uh, the relationship between rate constant and temperature is obviously okay. So this is the rate constant and the relationship between the temperatures known as the Arrhenius equation. So here K is our rate constant, A is just a normal constant, it can be any number, EA is our activation energy, R is our universal gas constant, and T is our temperature. So we need to find out a relationship between this K and T. First of all, you can see this is an exponential function. So obviously the graphs which shows a linear relationship would be wrong. Now when T is 0, okay, when T is equal to 0, I know that this base will be 0, so it is basically e to the power minus infinity. So K, if I mean when T is 0, K would be equal to e to the power a e to the power minus infinity. This means that e to the power minus infinity is again 0. So K equals 0. So K would start from 0, that is from this graph, and it would keep on increasing. We know that as temperature increases, our rate constant also increases. Okay, so for question 21, the correct answer is option C. So let's start with question 22. So in this question, we were asked to find out what would happen to the position of equilibrium when the equilibrium constant Kc when temperature increases. So firstly, when temperature increases, what happens is the temperature of the surrounding increases. By Le-Chatelier principle, we know that this reaction will try to reverse the effect. So as this is an endothermic reaction, as the reaction absorbs heat, what will happen to decrease the temperature of the surrounding? It will absorb more heat. Now this reaction is endothermic in the forward direction. So as the reaction proceeds towards the forward direction, more and more heat will be absorbed by this reaction. So the position of equilibrium will shift right when we increase the temperature. So either of option C and D could be the answer. Now let's check for Kc. Now first things first, whenever we are increasing the temperature, equilibrium constant can only be changed if we change the temperature. Okay, so by that logic, we can say that option C isn't the correct answer. Another thing that we know is if a reaction is endothermic, on increasing the temperature, your Kc or equilibrium constant also increases. It happens the other way around for an exothermic reaction. So in this case, option D is the correct answer. Now moving on to the next question. In this question, we need to find out which statement is correct for a spontaneous reaction. Okay. So by thermodynamics, I know that for a spontaneous reaction, delta G naught delta G should be negative. Okay, so delta G should be less than 0. So either of option A or B would be the answer. We know that. Now another thing, if the reaction has to be spontaneous in the forward direction, Kc should be greater than 1. Okay, so basically the logic says that if Kc is greater than 1, reaction is spontaneous in the forward direction. Or if Kc, if it's less than 1, it is spontaneous towards the backward reaction. Okay, so by these two logics, for question 23, option A is the correct answer. Now moving on to question 24, this question asks us that which of these oxides contribute to acid deposition. So this is a theoretical question mostly, but we know that oxides of sulfur and oxides of nitrogen actually contributes to most of the acid deposition. So option A is the correct answer for question 24. Now, moving on to question 25. In this question, we are asked which of these acids has the weakest conjugate base. Now, the general rule is stronger the acid is, weaker the conjugate base will be. Okay, so I'll just write the rule here. Stronger acid means weaker conjugate base. Now, to answer this question, we need to find out which one is the strongest acid among all these four options. Now, HCl I know is a very strong acid. Now, ethanoic acid, not a really strong acid. Okay, so I mean it's not as much strong as that of HCl. NH4Cl again is a weak acid. Last one is benzoic acid. It is also a weak acid. So HCl is the strongest acid between all the four options. So HCl will have the weakest conjugate base. So our answer is option A, and it's HCl. Now for question 26, we need to identify which of the following options is a Lewis acid but not a Bronsted-Lowry acid. Now, the characteristics of a Bronsted-Lowry acid is it should be able to donate H+. Okay, so not a Bronsted-Lowry acid means that option B and option D won't be our answers because both of them can donate H+ ions. So what is a Lewis acid? Lewis acid is basically an electron acceptor. Any species which can accept electrons can be termed as a Lewis acid. Now, basically two of the options are left, Cu2 plus and Cu. Cu2 plus on accepting a pair of electrons will give you Cu, while Cu after accepting two electrons will give you Cu2 minus. 2 minus. Okay. Now, obviously, we know that by stability Cu2 minus cannot exist. Okay. This is not a correct answer. But Cu2 plus can actually accept two electrons to become copper. Now, as copper, as you know, something which isn't charged is much stable than a charged species. So obviously, this thing is very much possible. So option A is the correct answer. That is Cu2 plus can accept two electrons to form copper. And that's why it's a Lewis acid. Now for question 27, you need to find the pH of ammonia solution that has this OH minus concentration. Now firstly calculate pOH. pOH is log of OH minus. That's minus log of OH minus, sorry. It would be minus log 10 to the power minus 4. So it's minus of minus 4. It's obviously log base 10. So our pOH comes out to be as 4. Now we know the law that pH plus pOH is equal to 14. So pH is basically 14 minus pOH. That is like 14 minus 4. So the pH of our solution is 10. So option C is the correct answer. For question 28, we need to find out the oxidation state of oxygen in the following three molecules. So firstly, in O2, what happens is there is no electronegativity difference. There is a non-polar molecule. So both of the oxygen atoms in O2 has zero oxidation state. So either of options B or C would be correct. Now let's check for OF2. In OF2, fluorine is more electronegative than oxygen. So fluorine would be assigned a negative oxidation state, while oxygen will have a positive oxidation state. So fluorine in general has a -1 oxidation state. Not in general, fluorine has only -1 oxidation state. So in this compound, you know, X minus 2 is equal to 0 as it's neutral. So X is basically +2. So oxidation state of oxygen in OF2 is +2. So from this two information, we know that option C is the correct answer, but let's check for H2O2. For H2O2, oxygen is more electronegative than hydrogen. So we know that oxygen will have a negative oxidation state. Now let's try to directly find out using a formula. For hydrogen, we know that the oxidation state of hydrogen when it's combined with a non-metal is +1. So 2 times, let X be the oxidation state of oxygen. So 2X plus 2 times +1 will be equal to 0 as it's uncharged. So that's why our right side is 0. So X in this case becomes -1. Okay, so the oxidation state of oxygen in H2O2 is -1. So yeah, option C is the correct answer. Now let's continue with question 29. In this question, it says that iron is a stronger reducing agent than silver. What is correct when this voltaic cell is in operation? So we need to find out which one will be the anode, which one will be the cathode, and what will be the direction of flow in the wire. So again, to solve this question, iron is a stronger reducing agent than silver. That means iron is the reducing agent here. So basically, iron is getting oxidized, while silver is getting reduced. Okay, so here what's happening is in this side we are converting Fe to Fe2 plus 2 electrons. Okay, and on this side Ag plus, this electron is getting converted to silver solid. Okay, so the part of the cell where oxidation occurs is known as the anode. Okay, the part of the cell where reduction occurs is known as the cathode. Okay, this information, anode is iron, cathode is silver. So any of the options C and D can be a correct option. Let's check for the direction of electron flow. Now electrons are generated on the right side, okay, and electrons are used on the left side. So right side has a excess amount of electrons. So these electrons will travel all the way from this wire to this electrode, where it will get used up to form silver solid. Okay, it'll get used up here. What happens is the electron is flowing from the right side, that is from the anode, okay, to the cathode. So for question 29, option D is the correct answer. Now let's start with question 30. So in this question, we need to find out which condition deposits the greatest weight of copper when solutions containing copper ions are electrolyzed for 10 minutes. So let's start by writing the formula. So we have derived a general formula, that is weight is equal to molar mass times current times time divided by your Faraday constant, that is 96500, times the charge on the ion. Okay, let's say the charge. Let's just write it here. So in this question, our molar mass will remain fixed, obviously, because it's copper. This is the Faraday constant. And the time is also constant because in all of the cases we are passing it for 10 minutes. Okay, so let's club these three together as we won't change it. T by 96500 times I by charge. Okay, so this is the weight. Now let's make it convert it to a constant K. Okay, so weight equals K times I times weight. In the first condition, or option A, your weight becomes K into 5 by 2, that's 5 by 2K. B, weight becomes K times 2.5 by 2. Option C, weight becomes K times 2.5 by 1. And in option D, weight becomes K times 5 by 1. Now all the four options, we see that option D has the highest value because K will have a positive value. Okay, and that multiplied by 5 would be the highest value as compared to K multiplied by 2.5 or K multiplied by 2.5 by 2 or K multiplied by 5 by 2. So option D is the correct answer here. Now for question 31, which statement is correct when the zinc spoon is electroplated with silver? Now in the process of electroplating, what happens is you would have two electrodes. One electrode will have a pure block of silver. This is a pure block of silver, and in the second electrode will be the spoon. Okay, and again this will be connected by a battery, and this is all inside an electrolyte. Now for any electrolysis experiment, we generally tend to have a conductive electrolyte, okay, such that ions can conduct within this. But we don't generally use this solution. I mean, we don't generally consider this solution to have the ions that are being used up in this reaction. What happens is these ions will interfere with this reaction. So option D won't be correct. Okay, we can't have zinc sulfate solution because zinc is an ion that is already present in the main reaction. Okay, now let's check for anode and cathode. So what happens is Ag will get converted to Ag plus and electron, and that Ag plus will come here. It will gain an electron and finally form Ag solid. Okay, so the Ag, that is the pure silver block, will act as the anode because oxidation is occurring through it, and this zinc spoon will be the cathode. This is because in the cathode you can see that Ag plus is taking up an electron. That means Ag plus is getting reduced. Okay, so anode is for oxidation, cathode is for reduction. So from the options below, cathode is silver. No, option C is the correct answer. The anode is made of silver. Now let's start with question 32. So in this question, we need to write the IUPAC name of this molecule. Now, firstly, to write IUPAC name, we need to identify the longest chain. I believe this is the longest chain. Okay, and the longest chain contains 1, 2, 3, 4, 5, 6 carbon atoms. So it is a hexene chain because there is a double bond here. So either of option B or option D can be correct. Now let's try naming this compound. Now what's the correct method of naming? That is the lowest low control. We have already discussed lowest low control in some, we will discuss lowest low control in some video. So stay tuned for that. But here I'm directly writing the rule. So 1, 2, 3, 4, 5, 6. Now we have 3 methyl groups. Okay, and the position of methyl groups is 2, 3, 5. So the name would start with 2, 3, 5 trimethyl, and then we would write the word root, that is hex, and the suffix would be from 1, the double bond starts with the second carbon, so it would be hex 2ene. Okay, so for question 32, D is the correct answer. Now in the next question, we need to find out which molecule will decolorize bromine water in dark. So for the rule for bromine water decolorizing a solution is that the solution should have a double bond or a triple bond. Okay, that's the rule we follow here. And in all of these, we can see that only hex 1ene has a double bond. So option C is the correct answer here. Rest of them all are saturated compounds. So obviously bromine water doesn't decolorize saturated solutions. Now for question 34, we need to find out a molecule which can be oxidized to a carboxylic acid by acidified potassium dichromate. Okay, to solve this question, let's just draw the structures of all the options. This is the first one. This is the second one. This is the third one, 2-methyl propan 2-ol. And this is the fourth one, that is propanol. Basically a ketone. Now what happens is acidified potassium dichromate can only oxidize that molecule which has an OH or a double bond O at the end carbon of a chain. Okay, or at the terminal carbon. Here in option B, C, D, check that double bond O or OH is present on the middle carbon, which is not exactly the terminal carbon. So option A is the correct answer here, because here the OH is attached to a terminal carbon. So for 34, answer is option A. Now moving on to question 35, we need to identify which is electrophile in the nitration of benzene. So basically for benzene nitration, if you remember, we generally add two things. Firstly is the H2SO4 sulfuric acid. Secondly is nitric acid. So the reaction goes something like this. You have this nitric acid. The structure of nitric acid looks like this. Firstly, nitric acid reacts with sulfuric acid. What happens is this OH tries to take away this H plus from this from the hydrogen of sulfur. What we get here is this thing, OH2 plus. Okay. Now in the next step, what happens is this negative charge on oxygen tries to form a bond with this nitrogen, and this bond breaks up. So finally what we get is this thing. So this is basically NO2 plus, and NO2 plus is the electrophile for the nitration of benzene. So what happens is the pi electron of a benzene ring, it then reacts with this NO2 plus, forms a bond with this nitrogen, and the reaction mechanism keeps going on. So option B is the correct answer to question 35. Now, in this question, we need to find out what would be the major product in the reaction between but1N and HBr. So but1N looks like this. Let's not draw it like this. This is but1N. So when we add HBr to it, if we have added peroxide, then we would have written the anti-Markovnikov product. But in this case, there is no peroxide added, so we will just have the Markovnikov product. That is, bromine would be substituted on the middle carbon, okay, or the carbon, the inside part of a double bond, and hydrogen would be added to the terminal carbon. So this is the correct answer. Now what's the name of this compound? It's 1, 2, 3, 4. So it's a butane chain. So it's 2-bromobutane. 2-bromobutane. So option C is the correct answer to question 36. So in question 37, we need to find out which molecule has an enantiomer. So for a molecule to be, and to have an enantiomer, it should have a chiral carbon. So what is the basic criteria for a carbon to be a chiral carbon? It should be sp3 hybridized. sp3 hybridized meaning that it should have all double bonds, no triple bond or a double. It should be all single bonds, no double bond or no triple bond. And another thing is all the groups attached to it must be different. So let's start with A. So we have CH3, CH2, COH, H, CH2, CH3. Now obviously these carbons cannot be chiral because you can see that it has 3 hydrogen, 2 hydrogen, but we should have all the groups different. For the middle carbon atom, you see that this group and this group are basically the same. So this carbon is not chiral. Okay. Second one, option B, we have CH2, CH2, CH, double bond CH2, and there is an OH attached to it. Now here you can see in all of these carbon atoms, here you have 2 hydrogen, 1 OH group. Okay, here you have 2 hydrogen, obviously it's not chiral. This carbon has 3 different groups attached to it, but it is not sp3, it is a sp2 carbon due to this double bond. So this compound also does not have any enantiomer. So going for option C, what we have is CH3, CH2, CH2, CH, triple bond CHBr. Okay, here again see these carbons cannot be chiral. These two also cannot be chiral because of this double bond. So we are just left with option D. In option D, what happens is you have CH3, CHBr, CH2, CH2, CH3. Now in this thing, check that this carbon has all 4 different groups attached to it. One is this CH3, one is this Br, one is this hydrogen, and one is this propyl group. So obviously option D is the correct answer to question 37. Now for question 38, this is again a very simple question. To solve this, firstly write out this formula. Now as everything is multiplied to each other, we can just write it as delta Q by Q is equal to delta M by M plus delta C by C plus delta T by T. Okay. Now as this C, it is constant, it doesn't have any error or uncertainty, so delta C would be 0. So this is not exactly delta T, it is delta of delta T. Okay, uncertainty in measuring this delta T. So delta Q upon Q would be delta M is 0.2. Okay. By M is basically 20 plus this delta of delta T is 1 and T is 10. So your delta Q by Q comes out to be as this thing would be 0.1, as this thing would be 0.01. So delta Q by Q becomes 0.11. To find the percentage uncertainty, we need to multiply delta Q by Q into 100. That is 0.11 times 100. That is 11%. So option C is the correct answer to it. Let's get to question 39. In this question, we need to find the index of hydrogen deficiency. To solve this, we have a simple formula. That is, let's design a general organic compound. So here C is carbon and small c represents the number of carbon atoms. H is hydrogen and small h represents the number of hydrogen atoms. N is nitrogen, small n is number of nitrogen atoms. X is any halogen and small x is number of halogen atoms. O is oxygen and the small o is number of oxygen atoms. So here if we try to convert this to this similar equation, so we get C6, hydrogen is 2 to the 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the formula. Now for this IHD, we have a direct formula. That is 2 times C plus 2 minus H plus N minus X divided by 2. Okay. Now as there is no nitrogen and halogen in this compound, these two things would be 0. C is basically 6 here. So 2 times 6 plus 2, hydrogen is 12. So H is minus 12 by 2. So upon cancelling, we see that IHD comes out to be as 1. So option B is the correct answer to 39. Now this is the last question. In this question, we have been asked which of the following can be identified using infrared spectroscopy. And in infrared spectroscopy, we know that only functional groups can be identified. So for 40, answer is option E. So with this question, we come to an end to the IBHL 2020 Chemistry Paper 1. In the next video, I would be solving the IBHL 2020 Chemistry Paper 2, that is the long answer type questions. So till then, keep studying. Also, don't forget to like this video and subscribe to our YouTube channel for more IB related contents. Till then, goodbye. Have a nice day ahead.